This is the presentation on System D. Joe!
What?
Laptop, man. It's so easy to spot people. So, how many people here know what System D is? How many people here have no idea what I'm talking about? Okay. How many people here know how a Linux computer starts up, or any computer starts up? Okay, so when your computer boots, two things happen. There'll be a graph of this later, but it'll make a little more sense. But basically, the computer does some stuff with a very basic image. In Linux, it's a kernel image. And then it passes that off to an init system. And the init system brings everything up and makes sure everything is coming online. Does a bunch of other crap. Linux used to have an init system called System 5, or sysv. And it was a bunch of bash scripts. And if you don't know what that means, don't worry. It was just sort of complicated, and all it handled was bringing stuff up. So it was just like this giant spaghetti pool of logic. I don't think anyone, well, I've written init system, or systemd init scripts, and it was a pain in the ass. If you haven't, you can't say it's good. If you have and you liked it, I am in awe. So that's what it is. But systemd is more than just an init system. So it was designed to replace systemd, which was the init system, but it also does server management, or service management. So like, this will make more sense later, but it does service management. And these are sort of the built-in things that you can't remove. These things you can sort of remove. It does device management via this thing called udevd. That was initially a separate project that now got merged into systemd. And it's pretty much impossible to boot without it, but it is sort of developed separately. And then it also does journal management and network management. And you can turn those on and off at will. And it does a bunch of other stuff that I won't talk about. That's why it's down here. But it has like a timer management system and a bunch of other stuff I don't remember. So the first question is, what is a service? So the official definition of a service is in the man pages. So basically, this is the blog of text. If you want to know more about what I spoke about, you should look at this. I'm not actually going to read it out loud. But if you want to know what services are running on your Linux machine, you can run system control. And it will list a whole bunch of crap. Anything that ends in service, like kmod static node service, or laptop mode service, or MPD service, is a service. Do you want to understand this? Okay. So MPD is my music daemon. So if I want to look at what it's doing, I can type this, and it will say, look, it's loaded, it's active, its process ID is 467, its C group is system slice npd.service, and it's running this command. So how it knows what this is actually is via configuration file. So every service file, or every service has a .service file somewhere in the file system. The ones that are like pre-shipped with systemd or pre-shipped with packages reside in user lib systemd system. So for example, user lib systemd system mpd.service. This is the music player daemon service file. It's got a description. It says you should start after the network target and the sound target, which makes sense because it needs network and sound. To actually run it, you run user bin npd -no-daemon, and if you want to install it, or basically make it so it always comes up, it should be started in time for multi-user target. An interesting note is that classically, Linux binaries would take care of like daemonizing themselves by themselves. And there's a bunch of stuff that sort of falls into this, and I'll talk about in a little bit. But this means that if you're looking in service files in systemd, they generally run with some variation on --no daemon, just because systemd covers this, so the binary doesn't, and in fact shouldn't, because then it'll make things more confusing. If you want to override these, there's sort of two classical places to override. Run systemd system is for, I guess, system overrides, or like transient overrides. So for example, there's a session1 scope file in here. That's this transient stub that was actually made because I logged in, and that is my session service. It's actually a scope, it's not a service, but it's the best example I have. And then the place where you should put your modifications if you want to modify stuff, by yourself is here. So for example, I have a custom OpenVPN service. It's pretty simple. Some other stuff like another OpenVPN service, a ZRAM service that brings up some devices, and it's probably not how you should do it, and like a screen lock service. If you want to override a systemd service, you can just make a new service file in etc systemd system, and that will just make it ignore whatever's in user lib or run. If you don't want to do that, or like you just want to extend it, you can make a folder called basically the service name.service.d, and it will add everything in that folder into the service definition and then run it. I don't do that anymore, so I don't have any examples, but it's pretty simple. Does anyone have any questions on anything I said, or is horrendously confused about everything, or particular things, or enjoying the presentation? Okay, some people are enjoying this, that's good. The last thing I'm going to talk about on this slide is systemd-run. So this is a command line tool. So you've got all these services running, right? And they're useful, but what if I just want to run like some retarded bash script? Like, let's say I want to run my backup script. I can just do systemd-run myBackup.sh. I have no idea what will happen when I do this because I'm pretty sure this script won't work correctly. But if it does, this will be very interesting. So it starts up the script, it's running as a specific service. I'll talk about how to do this later, but to look at the output, I can do this, and it complains because it looks like this thing's not mounted, and then it tries to mount it, and it can't mount it, and it fails because you can't do sudo inside a service. So that's a quick little utility. Secretly, all these services are actually just extensions on these things called systemd units. So a systemd unit is, I'm literally going to read this to you. A service, a socket, a device, a mount point, an auto mount point, a swap file, a partition, a startup target, a watch file system path, a timer, a temporary system state snapshot, a resource management slice, or a group of externally created processes. So basically, you can do a lot of things with systemd units. What it actually means is that, so if you look in systemd system that's into these services, there's a bunch of stuff. And the service stuff is all specific to services. And the install stuff is all specific to services that can be installed. But the unit stuff is actually generic. So all units have a description. That's what you see when you do something like, I think I have a temp mount. This, somewhere in here there should be a description. This is where, well, whatever. Okay, I can't find a description, but it's in there somewhere. You can pull it out.
The first line.
Oh, look, the first line. Awesome, you can find it. So that's where that is. There's actually a bunch of other stuff that can go in unit. So things like this unit starts after another unit, this unit requires another unit, this unit starts before another unit, this unit should be restarted when another unit's restarted. There's like about 100 options. So if you're interested in that, read the systemd.unit fan page. So that's fun. Another thing about services is that they're all started in C groups. And so what this means basically is this is a pretty, I don't know why my state is degraded, but this is a pretty standard like process tree. This is showing processes. So like this is your init process that came up first. It has a couple children. It has this system.slice, which has children, which has an openvpn.service, which has a child, which is an actual process. So basically, every service runs under a slice. Generally, they're running under the system slice. And so that's why there's sbin init, system slice, and like an openvpn service. And then every service is running in its own special thing called a C group, which is actually relatively complicated, but essentially it isolates it. So if you have a process running in a C group, no matter what it does, it can't make another process and get it to escape the C group. It's stuck in there, it's sort of locked in there. And so this is not that complicated when your services are like one process. For example, this is a service that brings up my wireless card. It runs this service, which actually does a bunch of different things because it's a bash script. But some of the things it spawns off that stick around are this, which does WPA decryption, and this, which gives me an IP address. And so rather than having to like worry about making them the correct children and monitoring them and killing the process when the service stops and bringing it up when it starts and all this stuff, it just launches them and sort of forgets about them and lets systemd manage them. So that's how the C groups work. Does this make sense to everyone?
Is that basically that the management of it is something that would have needed to have been handled manually with sysv init script?
Yeah, exactly. So with a sysv init script, if you're spawning a process and it has children, what it classically will do is it'll spawn its children and it'll write all the process IDs to files. I don't know where they would go, like var Apache children and then something.process ID, but it would write all those process IDs and it would manually call system call to that process ID to kill its children, to bring them up. Sometimes the children would be killed by like you because there's an Apache process that's going insane, so then Apache would try and kill it and it was already killed, stuff like that. Generally processes would also do this thing where they would basically double fork. So they would like spawn a child and then remove that child from being their child so that it would be able to run without being killed if the parent process was killed. And this was called daemonization. But it was a huge pain in the butt and every program had to do it and most programs did it incorrectly. So like you'd run a program as root, it would set some stuff up and then it would fork, and if that fork like didn't drop permissions correctly, it was suddenly running as root, and if you seized control of that process, you could become root and do a bunch of nasty stuff. So that's one of the things that's nice. Anyone else have questions about this? Okay. So this is the process tree and the slice service scope tree, I guess. Here are all my user processes. They're all running under one scope, which sort of makes sense. That's pretty much it for there. So you got a bunch of processes and services and mount points and all this other crud. And the question is, how do they actually come up? So systemd also takes care of this. I'm going to start with showing you how to like look at the process, and then we'll talk a little bit about how it figures out what to do. So systemd comes built in with some decent analysis tools. So if you just type systemd-analyze, it'll tell you how long your startup took. So it took 17 seconds kernel, 915 milliseconds user space for a total of 18 seconds. If you want to see what took so freaking long, you can run this. It looks like starting systemd user session service added 9 milliseconds, and starting systemd RF kill added 16 milliseconds. If this doesn't really tell you much, or you just want to look at processes that took forever, you can run blame. This will sort them by time. It looks like what actually made everything take forever, or at least the longest process that's required by multi-user that what took a while until it came up, was net control at RPI. This actually sort of makes sense because net control at RPI can be enabled, but I don't do it. I actually run it once I've logged into my system. And it has to connect to the RPI wireless, set a WPA, get a DHCP address. And for anyone who doesn't know, RPI's DHCP servers take forever to respond. So that's the real problem. I also
You summed more than 18 seconds.
Yeah, I know. That's because systemd analyze blame doesn't actually just show you the systemd services that were running at boot. So I've suspended my machine since I booted, and so it's giving me the time output for systemd suspend.service, which suspends my machine. So this is why blame isn't super useful. It's really there to tell you which services took the most time, not the most time in your boot. If you want most time in your boot, you should run critical chain. And if you want to know exactly what they do, I recommend reading the systemd-analyze man page. So for example, blame prints a list of all running units ordered by the time they took to initialize. Note that the output might be misleading as the initialization of one service might be slow. Oh, because it waits for children. So I guess that sort of answers your question. Critical chain prints blah, blah, blah. You can read the man pages. So that's the simple usage. That's blame critical chain. Another cool thing you can do is you can output a plot. So you can get it to actually plot your boot. So this is my boot time. It is so beautiful and brilliant and off the page. There's a chart down here, so like activating, active, that's really what matters. I don't have security modules. I don't really use generators. I have an SSD, so loading unit files is pretty much instantaneous. And I don't think I deactivate anything in this. So this is my actual boot. As you can see up here, took the kernel 16 point something seconds. That's mainly because I have to decrypt a encrypted partition. So it waits for me to type my password, which took me about 11 seconds to notice that it had turned on. And then it takes 5 seconds to convert my password into the actual encryption key. And then it mounts and it goes. Normally it takes 1 second, just for my own like pride in the Linux kernel. It's not its fault, it's my fault. And so systemd is the first thing to start. These time differences are sort of microscopic, but it brings up dash.mount. So basically this is the root mount, so my root file system. because the kernel is actually running in this like special kernel image that has some stuff in it, but it's all gzipped together. So it's not actually reading anything off the file system. And then start systemd ask password wall.path, which I guess is some path to let you ask me passwords. It starts with my remote file systems. There are none. This is pretty fast. Yada, yada, yada. Set up some encrypted drives, set up paths, set up swaps, set up my data directory in my home folder. This is all boring stuff. Start the journal service, bring up an enormous amount of devices. So like here's my SSD, here's my other hard drive. I don't know what some of this is. Here's a bunch of serials and DUIs, things like that. And then this is where all the services tend to come up. There's system services. Somewhere in here is where my monitor actually comes up, which was hilarious because it takes my monitor much longer to start up than the rest of my system. And it used to be that I would boot my machine so fast my monitor wouldn't come up in time for my login screen to display. So my final graphical login manager would always crash. That was mainly NVIDIA's fault though, not mine, not the driver's fault. So that's that. Also, if you want even more information, there's this thing called systemd-boot chart. Basically, you change your init path from systemd to systemd-boot chart, and then you look in, run log, and it produces a pretty picture. And this pretty picture is pretty similar to what you saw before. It's got all this stuff. It's got a little bit more information, and it goes for longer, because it waits for a user to actually log in, but it also gives you I/O utilization, CPU utilization, and processes. So this is my I/O speed. My maximum read speed was 426 megabits per second, which is pretty good. This is my CPU usage. I think this is actually CPU and this is I/O wait times. And then this is the number of processes I had. Does anyone have any questions about the pretty picture? Or anything else I've said? All right. So that's a bunch of stuff for analyzing your init path. To actually figure out how it works, there is a command, I might remember it, to actually get systemd to tell you why it did its calculations. What is that called? I don't know what it is. Although this is a useful command that will tell you where your processes are coming from, or where your services are coming from. So like I've overridden the DAPST and masked my root file system check. Okay, I don't see it, but basically what systemd does is it loads all these services and it knows what you want. So in this case, my default target is multi-user. I think you can actually find that at the systemd system. Let's see, system. There is a default.target symlink. In my case, it points to graphical.target. If you look at graphical.target, it points to nothing. So graphical.target is my default target. So when I build my machine, it wants to move to graphical.target. Graphical.target is actually this multi-user.target, mostly, plus a couple other things, which I don't have installed. So it's secretly just multi-user. So basically what systemd does is it goes through your targets to figure out what it wants, and then it just walks down what's required for that target. So my multi-user target, a bunch of stuff's required, and it figures out what those things require, and it just walks the entire tree. And it does it pretty quickly. It's not that hard, it's like, I don't know, maybe a 200 node tree. So that's how it figures that out. If you want to know more, there's actually a command that will have it output what it generated. I don't know the name of it, and I don't remember how to use it. I've never had to use it. So that's that for actual core systemd. Does anyone have any questions on it? Oh.
I was just wondering, so systemd, is systemd supposed to be kind of a replacement for the init.d system?
Yeah, it's a complete replacement for init.d. Although it will run init.d scripts in backwards compatibility mode, so you can still use them. I don't think it's set up on Arch at all, but some other systems do have that.
If you've got a system running Upstart, is there a way to migrate over, or is there?
If you have a system running Upstart, you're in for a world of pain.
Yeah.
But you can switch to systemd. How do you migrate it? I actually have zero idea how they're going to do that migration. Upstart's interesting because its unit files are actually just bash scripts that are calling through to bash commands, and that's why I can't do certain things like C groups and stuff like that. Because until recently, there was no way to do that through bash. You actually can do almost everything in systemd through bash, but that's a more advanced topic. In reality, you should probably just write a systemd unit file. They're a hell of a lot simpler than Upstart. They're sort of similar in lots of ways. All the parameters change names, mostly. And the logic works. So like in Upstart, once you get nested beyond a certain level, you can write the logic, but it doesn't work at all. In systemd, once you get nested beyond a certain level, it still works. So that's sort of interesting. Honestly, I have no idea how you're going to migrate that. Probably just rewrite everything into systemd. Speaking of which, the RCOS server uses Upstart. So if someone is like really gung-ho about Ubuntu, when they do that migration, if you want to migrate the RCOS server, I will give you root access and not pay any attention. Boric?
Can we take a pizza break?
Oh shit, no one has been eating pizza. You guys are too polite. Of course, get pizza. Should have revolted like 20 minutes ago. Systemd has a component called udevd. So when a Linux machine boots, the kernel starts up, and then it notices when devices come online, but it doesn't automatically bring them online. For various reasons. One of them is that they don't have to map devices and USB things to kernel modules, and that would be a pain in the ass. And two, because they just didn't want to deal with it. So the Linux user space handles this. There were a couple things that would do this. The one that has done it successfully for the longest number of years is called udev. And it ended up getting merged into systemd, or at least the systemd source tree, because the same developers worked on both, and they were integrating a lot of stuff between them, and it was sort of silly to keep them explicitly separate. This also causes minor political battles that you can read up on if you're interested in. I'm not going to talk about it. But basically what this does is the kernel says stuff comes online, it looks at what comes online, and it tells the kernel to use these kernel modules on it. So again, system control. So pretty much everything that's like a sys device, this was all started by udev. If you really want to see what modules are loaded, you can type lsmod. It's a giant set of output, but that's pretty much what udevd does. If you want to read more, read the man pages. I'm not going to read them. Does anyone have questions about it? So if you're ever asked an interview, what like inserts Linux modules and like gets devices up on the Linux system, you'll say it's a combination of the Linux kernel and udev. Everyone agrees with me here? Or will blindly obey me? Okay. The most controversial thing about systemd was, oddly enough, this thing called systemd-journald. It's a service, it runs, it collects and stores logging data. For a very long time, Linux had this habit, or I don't know what you call it, an idiom, something like that, where everything would store in var log. And so you still see some stuff here. So like if you want to look at the things I've done with Pacman, you can look in pacman.log, and it will dump a bunch of stuff. Looks like I was messing around with Pipelight recently, mainly because I broke it in a very annoying way. But this is how Linux used to work. Everything would set up logs. And what was sort of annoying about it is that you would actually have logs that would get too big, and so they would end up getting rotated. So like xorg.0.log has been rotated. This is the most recent log. You can see that I loaded my NVIDIA driver, and then 1.log is an older log. Apparently there was some sort of error with BT activate failed. I don't know what's up with that. And so you would end up with these large files, so you'd have like xorg.0.1 up to 9 or beyond, and then it would start gzipping them, and so you would be digging through these files. It would be sort of a pain in the ass. It's not that horrible, but it was annoying. And what's also annoying is that processes would have to change their standard output to dump to this log file, or they'd have their own logging functions or something like that. So every process basically would re-implement logging from the ground up. This is part of the reason why it can be tricky to figure out what's going on in the Linux system if you don't understand how the program you're using logs its stuff. And so systemd, because it was doing everything in C groups, could actually just take the standard output from our process and always dump it to a log. That's part of one of the reasons that systemd processes typically don't daemonize, because that way you get debug output and it dumps the standard out, which is automatically sent into a log file. So if you want to look at your log, you type journal control. This is my entire journal, every log that's ever, this is my entire log, so everything that's ever hit journal D. It starts at the earliest entry and goes down. So for example, this is my boot on February 21st, 1 o'clock in the afternoon. Looks like my journal was using 1.3 megabytes, and here's a bunch of kernel stuff. So if you don't want to do that, you can do -R, which will reverse the log and show you the newest stuff first. Here you can see me running sudo a bunch and some kernel stuff and my VPN coming up. If you want just since the last boot, you can do -B. So this is basically how you access the systemd log. Some fun stuff to note. It has the process, or the service, and then it has the process ID. What's interesting is that actually on the underlying side, this is all stored as binary data, and this is the actual log, and then the rest of this is all generated from metadata. So classically what you do in your log format is you like put a process, and then maybe you put a timestamp, and then maybe you follow the rest of the classic Linux conventions, and I don't remember what they are, and then you put your log. And everyone sort of expected files to be in this format, and they were mostly in that format, and there were generally some subtle differences, and it was a little bit confusing, especially timestamps, because classic Unix timestamps just have the time, not the time zone. So if you had a server that had the wrong system time, or was like in a different time zone, stuff could start getting hairy. And what's also true is that's all the metadata you got. So what systemd actually does is when you log something in it, there's this giant dictionary of metadata attached. Things like process ID, process, service, C group, a whole bunch of other stuff. I honestly can't remember it all. I very rarely use any of it. But there are shortcuts to access pretty much all of it. So you can set units, you can set the time. I don't know what else you can do here. I think -X. Oh, it adds message explanations. I think there's a way to see only certain priorities, stuff like that. So that's all in the systemd log. Does anyone have questions about this? It does other nice things too. So classically, kernel logging occurred in this thing called dmessage, which is basically just a ring buffer that the kernel kept in RAM. And that normally isn't dumped to var log. Systemd reads that when it starts journald and puts it all in there as well with the right timestamps. So you can see your kernel messages in here as well, since boot actually. And because journald is one of the last things to go down, you get boot logging almost all the way through until you unmount all your file systems. So that's nice as well. Makes figuring out why your system didn't shut down a little bit simpler. Any questions about this? Anyone want to murder me right now because they really hate journald and would rather just use classic syslog? Great! You know that journald can output the classic syslog, right?
I did not.
Yes.
Why is it a political issue?
Why is it a political issue? Because people didn't like systemd, and one of the big complaints was that it was this giant monolithic binary that was seizing control of everything. And what was classically cited was journald, because look, they rewrote the log and you can't turn it off. Journald is actually a separate binary and you can turn it off, but you know, arguments versus rhetoric versus actual facts, stuff gets confused. Especially if you don't ever use it, you don't really know much about it. So that was, I guess, why there was a battle. There's been some other battles about like switching the default logging system in various distros. Like Fedora tried to switch away from the default logging system being syslog to being systemd journald, and that didn't work out so well. But most other distros that are bleeding edge switch. So, you know, whatever floats your boat. If you want more, I can tell you more and give you links to mailing list archives where people are yelling at each other and apologizing and standing down from committees and invoking political analysis. There's some other cool things that exist with systemd. So systemd networkd is relatively new. No one's ever heard of it. Most people haven't heard of it. But basically, it can do all your networking for you. So it can do pretty much everything that requires an Ethernet cable. Sorry, I'm trying to figure out how to, oh, that's the problem. So if you need like a wireless card, systemd networkd won't work for you. But if you just need to bring up an Ethernet card, it will. So I'm SSHing into a server, which should be coming up, where all I use is networkd for my networking. Oh, it's still coming up. There we go. So this is Stalin. It's a server in New York Data Center 2 for DigitalOcean. In reality, it's one server on like 20. It's like one of like 30 something servers running on a beefy machine. It has basically nothing running. It runs my VPN and my IRC bouncer. And lets me VPN into my apartment over there because their firewalls suck when you're coming in from Sweden. But it does all its network configuration via systemd network. Let me just think if I can remember. So how systemd network D works is just like everything else, you write a unit file. In this case, you put it under etc systemd network. I call it static.network. It's pretty simple. There's a match clause that says what interface should this match. In this case, it matches the interface called ENS3. If you put nothing there, it matches everything. You can have it match on MAC address, interface type, interface, host name, a bunch of other stuff. So if you have like 100 virtual machines and they all have host names that indicate what they should do, and some of those should bring up different networking, you can just dump the same config on all of them and have the match clauses be different, and it will match the correct network config to the correct machine. The network's pretty simple. This is just statically allocated. So my address is 162.243.179. My gateway is 162.243.1.1. My DNS is the Google public DNS because DigitalOcean doesn't provide their own. That's pretty much it. It can do DHCP. It can do DHCP link local. It can do DHCP for IPv6. I don't do any of this on this machine, but you can if you want. You can inspect the status, system control, status, static.network. I thought you could do that. I don't actually know how to inspect those statuses. Someone should probably figure it out who's not me in the middle of the presentation. So that's systemd network D. It's new, it works. If you need something simple, it's probably the lightest weight thing available. That's it. There's a bunch of other cool things I didn't have time to like prepare demos for or mess around the command line. So all the systemd stuff you can actually do remotely. I don't remember the flag, but pretty much all those utilities I was using, you can tell them to connect to a different machine instead. And provided you configure that machine's systemd utility correctly, it will work. Systemd works pretty well with containers, virtualization, etc. It has built-in support for like auto-spawning containers when someone hits a socket and then spawning systemd instance inside that container, so you can pretend that's a complete separate operating system, and having that systemd instance spawn another socket which spawns a service. That sort of thing. It detects virtualization. It can handle that. If you're interested, I can tell you how to mutilate your boot order to make your machine boot in under 2 seconds. It's sketchy as heck, and it's sort of a miracle that it boots, but it does. And there's a whole bunch of other stuff that I don't look at on a daily basis that exists. If you're interested, you should read about it. So that's pretty much it. Thanks to the usual suspects. Are there any questions? Luke?
Yeah, how do you respond to criticism that systemd is bloated and doesn't abide by the Unix philosophy?
Actually, I'll ask you. That is how I respond to your criticism.
It might be a small binary, but you can't deny that it's packing a lot of different, orthogonal programs into one package.
It's one package, but they're separate binaries if you can run without them. For example, I will disable my terminal. And look, I just stopped my journal, and all my logging just broke. If I wanted to, I could still, well, if I was on a distro that still bothered to package syslog, I could reinstall it. I don't think Arch does. But most of the stuff people bitch about, it's in the R if you really want it. I don't know why the hell you would. But if you do, you can install it. I'll prove it to you, David. Watch this. Oh, okay, it's not in the R, you're screwed. Actually, I think syslog is actually called rsyslog D, now that I think about it.
That or just like NG.
Yeah, there we go, rsyslog. So I installed syslog, and I'm already regretting my decision. So I'm not going to figure out how to configure it and start it, but I could. So, first criticism is that it's loaded as hell and it has all these features. And you're right, and they're all separate features for the most part, except for core process management and init and UDEV. The first two because it's really hard to separate process management and init when you're using the second for the first and figuring out how to init by walking your service tree. And the second because I guess you could peel off UDEV-D, but then you'd have no devices on your Linux machine and you couldn't get keyboard input. So good luck there. I don't even think it's possible to compile without it anymore. It used to be. Because it used to be that they would compile separately. But if you want to strip it off, I guess you could figure it out.
What system was used prior to UDEV-D?
UDEV-D is like, I think 10 years older than systemd. I have no idea what they used before UDEV-D. I don't think I'm old enough to know what they used before UDEV-D. Does anyone have, oh, HAL. They used HAL, which was this hardware extraction layer library. I think that's what they used. I think it was HAL and something else. But that got removed in like Ubuntu 8. So 6 years ago, I think. Any other questions? Okay. It is 49, so I'll keep answering questions for 40 seconds. Then you can all leave, and if you have questions, you can come ask me. But first, John, go. Question.
Okay. How do you respond to the criticism that systemd is a really big thing to be process number one?
It's 1 megabyte.
But it should be really small so it doesn't break.
What's also hilarious is that the systemd process 1, unlike sysv, where the first process just sat around forever, is actually what's handling all the systemd IRC. So like it's handling services, and it's handling you telling it to start a service. It actually talks to VDUS to systemd and starts it. So it does more shit than normal. I don't know. I think 1 megabyte's pretty light. I have 8 gigs of RAM. I actually think 1 megabyte's fine. And I uninstalled MPDB to install Cronny because it was lighter. So that's it. Get out of here if you have questions. Talk to me.